this video, we will go over example 6 in section 3.6 marginals for math 261 applied calculus 1 students. This is one of your homework problems. So it says that R of X, C of X, and P of X, revenue, cost, and profit, be respectively the revenue, cost, and profit in dollars from the production and sale of X items. All right, so they're giving us some functions. The R of X is 4X. The revenue function is just 4 times however many items being sold. Next, C of X, the cost function is a little bit more complicated, looks like. Is that one right there? So what do they want? They want us to first, part A, find P of X. They want us to find the profit function. Now remember, P of X is simply R of X minus C of X, revenue minus profit. So let's find that P of X. I'm going to subtract the revenue function, which is 4X right there, minus the cost function, okay? And now let me get that second cost function out of that parenthesis by switching the sign. So that plus 1.7 is now minus 1.7x. And that plus 60 is now minus 60. Let's see if there are any like terms. And let me go ahead and just write this in a prettier format, like in standard form. I'll bring that square term or that quadratic term to the front. Negative 0.004 x squared. But there is like term. Let's combine 4x and minus 1.7x. 4 minus 1.7 is 2.3. So plus 2.3x and then that minus 60. So part A, done, we found it. Now part B, they want us to find, let me copy this so that it kind of tells me, oh, it's clear that I'm finding part B now. I just need to plug in 100. So if they produce and sell 100 items, what will be the revenue, what will be the cost, and what will be the profit? So all we need to do is just plug in. So R of 100 is, remember the revenue function was simply doing 4 times X, right? 4 times 100. So that will be $400. Okay. The cost at 100, that's the longer one, right? 0.04 times 100 squared plus 1.7 times 100 plus 60. What will be the cost? I'm going to need a calculator for this part, right? So I'll open up a calculator. Oh, there's one right here. All right, and I'll go ahead and type this C of 100. Negative 0.004 times 100 squared plus 1.7 times 100 plus 60. And that comes out to be $190. So the cost of producing and selling 100 item is going to be $190. We can plug in 100 into the profit function, but we don't need to. We can just subtract. So we can say P of 100 is equal to R of 100 minus the cost C of 100, which is 400 minus 190. So the profit for making 100 of these items will be 400 minus 190, and that is $210. Nothing calculus about it just yet, but oh, there we go. Part C, take a look. We need to find the marginal revenue, marginal cost, and marginal profit function. Simply just take the derivative of each of these functions, and that will be it. So let me see. I think I'm going to try to squeeze in the work on the same page here. it's asking for a lot, but I don't think we're doing a lot. I don't think it's too difficult, right? We're just working with each function. So r of x, remember r of x was simply 4 times x, right? Let's just double check. R of x was 4 times x. So derivative of 4x is 4. It's positive 4. So per every item, additional item sold, revenue is going up by 4. Okay. How about c prime of x? It will be helpful to have c of x right above it or something so that I can just take the derivative. So let me copy this real quick down there so that I can look at it to take the derivative. Okay, so what's that going to be? C prime of x will be, I need to first multiply 0.004 by 2. So that is point. Now hold on a second, was it negative? I can't remember. I just had to double check. No, it wasn't negative. The profit function was negative, but the cost function, the leading coefficient was positive. So 0.008x plus 1.7, and that's it. That is the derivative. Let me delete this. I don't need it anymore. All right, let's find the p prime of x. Okay. What was p of x that we found? Let me go grab that. Here is that p of x. I'll go ahead and copy this real quick and put it here so that I can look at it as I'm taking the derivative. So we're taking the derivative of this function right here. So I need to multiply this leading coefficient by 2, which is negative 0.008x. And then I need to take the derivative of 2.3x, which is plus 2.3. So that is our prime, p prime of x, okay? Oh, you know what, guys? Maybe we could have done it this way. What if we subtract r prime of x minus c prime of x? I have a feeling we're going to get the same answer, right? So let's try that. What if we do 4 minus 0.008x plus 1.7? If we do that, we will get 4 minus 0.008x minus 1.7, and I can bring that negative 0.008x, and oh, whoopsie, sorry, you could not see what I was writing. And now I'm combining the like terms. If I do 4 minus 1.7, 4 minus 1.7, I get 2.3. 2.3. Yeah, that was 2.3. I clicked on equal sign one more time. 1 minus 1.7, that comes out to be 2.3. So, okay, so just did it in a different method, 2 different methods. Or you can do this, and you notice the answers. This matches what we got. So to me, honestly, just taking the derivative of p of x was easy, but if you want to subtract, that works too. Okay? All right, so that was part C. Let's do the last part of this example. I'm going to need to add a page to this. All right, hold on. Part D is asking us to find the marginal revenue, the marginal cost, and marginal profit at the moment they produce and sell 100 items. It's easy. We just have to plug them in to these derivative functions that we found in part C. So let's do those. First of all, r prime of 100 is equal to, look, the r prime function was a constant function, just 4. So we can say $4 per unit. I'm just trying to put the unit here, okay? Next, C prime of 100. I'm going to need to plug that into C prime of x. Okay, so what's that going to be? I will get 0.008 times 100 plus 1.7, which is 0.8 plus, hold on, I'm getting a phone call, hold on. I'm back, so let's add 1.7 to that. 80 cents plus $1.70 is $2.50 per unit. So for an additional 1 unit they make and sell, the cost is going up by $2.50 when they are making 100 units. All right, how about the last one? P prime of 10, P prime of 100. Now I can plug this into the derivative function that we found, or we can just subtract r prime of 100 minus r prime of c prime of 100. But you know, why not? I'll go ahead and just plug it in, and I will also subtract to see if we get the same answer, okay? So if I plug it into this p prime, the marginal profit function, I will get negative 0.008 times 100 plus 2.3. So what's that going to be? That is negative 0.8 plus 2.3. So $2.30 minus 80 cents. $2.30 minus 80 cents. The marginal profit is $1.50 per unit at x equals 10. So $1.50 per unit. Okay, at the time they produce and sell 100 units. So let's see, what if we use that subtraction method? Or you can do P prime of 100 equals R prime of 100 minus C prime of 100. If you subtract $2.50 minus, I'm sorry, that wasn't the R prime of x. R prime of x was $4, sorry. So if we subtract $4 minus $2.50, wouldn't we get $1.50 per unit again, right? So two different methods. Honestly, I think for this one, I would just subtract, but just wanted to show you that both way works. So that was example number 6 on section 3.6 marginals.